All right, so let's say Shinkus, there he is again, a researcher, found a difference between two groups. The p-value was lower than 0.05. Calculating the power of his test is therefore no longer relevant. That is that thinking error that we talked about. So the error goes something like this: p-value is lower than 0.05. I found an effect. When I found an effect, is no longer relevant what the probability is that I find an effect. And that sounds somewhat intuitive, right? I've already know that there's an effect, so checking the probability of finding an effect, if it exists, is no longer relevant because there it is. And there's two ways of thinking about this reasoning error. One is that rejecting a null hypothesis doesn't mean that the effect actually exists. No, you're performing a behavior that is justified and has an error rate, right? A 5% error rate if the null is true, 20% error rate if it's not. And you don't know whether the null is true or not. So you don't know whether you're making a mistake at this specific moment. You just know that there's a certain probability in the long run. So that's a central confusion here, is that people confuse the fact that they reject a null with the probability, they reject a null with there being an effect, which there doesn't necessarily have to be. Another way of looking at this, and again, you don't have to do these calculations right now, but if we, let me check. I don't know whether I changed this accordingly. Yeah, so I'll just give you the results of the calculation. So you can use that frequency tree again, and you can plug in different values for power in this case. So I kept the other factors constant. So I used the same base rate, and I used the same alpha level as I did in the previous example, but I changed the beta level. So I changed power. And if you then look at the probability that you're dealing with a real effect, given that you just rejected the null hypothesis, and you look at that probability in the case in where you have low power and the case in which you have high power, then you see that that probability is different. So the probability that indeed, given that you've rejected the null, that there is a true effect in the population, would be higher in the high-powered case, and it would be lower in the low-power case. That means that the usefulness of you rejecting the null, or the degree to which that reflects an actual effect in the population, is affected by the power of your study. And that's another reason to conclude that the fact that you found a significant result doesn't mean that power is irrelevant. The fact that you rejected the null is more informative if you have a high-powered study.